All right. Okay. Well, welcome to this second webinar, which is informing you about the EUDIS Hackathon specific topics. And the hackathon takes place in October from 17th to 19th at the Space Campus in the Comet Lab. So I will share my screen and provide you an overview of what we're going to do today. So you should see my screen in presenter mode, right? Yeah, you see it in presenter mode. Okay, good.
Yeah.
So what we're going to do today, today we will provide you some specific information regarding topics of challenge 2. And therefore we have two guests, Mr. Sonny Lie from NLR and, oh, that's not right. And Mr. Michiel Selier from Axiom Space Systems. Sorry for this, Michiel.
No worries.
We'll provide.
Sonny will take the heat twice, and I can relax. So.
Yeah. Okay, good. We will give a presentation about the PAMI project, which is specifically for the Dutch Defense Organization. And then we conclude with some Q&As. If someone wants to do a pitch about looking for a theme, challenges, or whatever, he's or she is happily invited. And then at about 5 or I think 5:15, we will conclude. So for those who are, let's see, there's some people in the waiting room, so I will admit them all. Yes. So good afternoon. We were just starting, so I will provide you a bit of an overview what we're going to do during the hackathon, who is the organizing committee. So as you see, we have a multi-partnership, a multi-stakeholder partnership. Ministry of Defense is involved, of course, and TNO and NLR as knowledge partners. And furthermore, we have the economic board in the province, which are the regional authorities. And we have the incubator SBIC Noordwijk, which is the space incubator located near STRIJK. And of course, the Regional Development Agency Innovation Quarter and NL Space Campus, which is managing, organizing the space cluster in Zuid-Holland. Then today on the menu is the space for defense. So dealing with topics like Earth observation, navigation, communication, and so on. The two speakers of today will address some of these elements briefly, and hopefully they might inspire you for the challenges which you're facing during the hackathon. And in the webinar of next week, we will address challenge 3, dealing with unmanned aerial vehicles, countermeasures for drones and so on. And we will have at least 2 speakers from the industry, so from the startup side. So where's the hackathon? It's in the Comet Lab on Space Campus. It will be opened. The opening is the 7th of October. So we will be one of the first groups who will use the facilities over there. So everything should work perfectly. And for the accommodation of participants, because we cannot stay overnight, we arranged some hotel vouchers. So, and this will cost 30 euros for the full weekend, so it's 2 nights including breakfast in a nearby hotel. And this is a new sheet, Magdalena, compared to last week. So an overview of the equipment which is there, and this is just a snapshot. So it's a machine shop and electro lab. So equipment is there. So it can be used under some guidance, of course, because when it's it's all brand new and it has to be. We have to look for some kind of a schedule during the hackathon. If you want to bring your own tools, then please do so. So then you have access to the appliances which you need. There is more, but I will update the list next week in STRIJK, I don't know, or on our webpage. So the mentors, so technical experts from Mine, TNO, NLR, and so on, which are there. So today I connected with the Ministry of Defense, so this is also organized, and the jury members. So we already had a few, but then from the economic board of the Duin en Bollenstreek will participate in the jury Mr. Ben van Bergen Henegouwen, who is also the owner and CEO of West MBV, who is a contractor for STEC, but also for defense. The prize is €3,000 plus support, €1,000 and support, and €500 and media exposure. This hasn't changed compared to last week. And then my call to action is register now, but Marjolein already registered, and PB, I don't know. And the others, which I don't see, Hilp did register, I know. The others maybe, so I can check it on the list. I will do this tomorrow, so see your name there again. So this is the presentation which I wanted to share with you. So let's now quickly go to Sonny from NLR, Business Manager Space, and I will give him the floor to entertain you and to inspire you. So Sonny, the floor is yours.
Yes, thank you, Martijn. Good afternoon, everyone. My name is Sonny Lie. I work as a business manager for Space, and I will show a bit more about the R&D on Space for Defense. So I'll start sharing my slides. So in this presentation, I would like to highlight a little bit more about the need for R&D in space, what the direction is within the current trends, and also what we are doing as NLR on the topic of space for defense. So without further ado, I'd like to dive into the presentation. This is just a logistic part that this presentation will also be shared with you after this presentation, so you can have a look at it after it. What I really like about Challenge 2, so Space for Defense, the Earth observation, navigation, and communication and coordination of the multi-domain operations, is that it actually quite nicely aligns also with the goals of the Dutch MOD, which has been laid out in the defense space agenda, but also on the overall direction of the EU regarding space as a newly identified warfighting domain. It has been identified as the 5th warfighting domain next to air, land, sea, and cyber. So it's really good to see that Europe is acting on this now and really pushing to accelerate the innovation within the space domain. And here in this slide, I've listed what the Dutch MOD has defined as required defense capabilities in the space domain. Highlighted in green here, I have these more specific topics that I think align very nicely with Challenge 2. Bullet point 3 and 4 here, I think, are mostly aligned with Challenge 1, which is more the protection of space assets. So for the first one, the Dutch MOD has identified that they really want to ramp up their Defense Space Security Center, so making more people available for space operations, and also building up the expertise and building up the satellite capability. So in 2021, they've launched their first satellite, the BRIC-2 satellite, with Dutch partners, and 2 years later, in 2023, they've launched 2 more satellites with Norway, Birkeland and Huygens, where we as NLR were also involved. And it's nice to see that they're really ramping up their satellite capability and also expresses their need for more military operations in space. Then I would skip 3 and 4, but going into satellite communications, this of course is providing SATCOM to the other domains as well. So think land, sea, and air, being able to provide this as a capability from space but also closely related to cyber domain. Of course, you want to have your satellite communications as secure as possible, and being able to react to disturbances. So that's what they're focusing on in the satellite communications domain. For position navigation and timing, they're also highlighting that they want to explore what the possibilities are in using Galileo, but also the more robust services of Galileo, so the PRS service, the public regulated service, how they can employ this and also be more resilient to disturbances. Of course, in the past few years, we have seen that the GNSS signals are being disturbed, being jammed, being spoofed. So they're looking also towards alternative methods to still be able to do accurate position and navigation and timing for mission critical services. On the shared early warning topic, that's where we really see a very nice European collaboration. Of course, being able to detect threats early is very important for ballistic missile defense. And there, within the shared early warning domain, we see also close connection with satellite communications, as once you have achieved a certain warning, you want to relay that information as fast as possible to the sensors and the weapon systems to take countermeasures to this threat. Then for intelligence, surveillance, and reconnaissance, this can be an ongoing effort, which could be a request from the other domains. So for example, from land or sea or air, where they want to have very specific data from space that they cannot achieve with their own assets. But from space, you can have a more broader coverage or have specific sensors that can detect specific signatures and then act upon that and bring really those most critical information to the end users. That's what in the topic of ISRs and being focused on. And finally, the ninth topic, the intensification of research and technology development. I was very happy to see this also in the defense space agenda, because I think this also really emphasizes the need for these kind of hackathons as well, to really push the innovation and accelerate for the space domain. So next to the long-term innovations, also to these kind of research and technology development on a shorter notice, and being able to accelerate the ideas that can be brought for defense as well. So I hope this gives a bit more information on what kind of projects, topics you can think of within Challenge 2. And next to that, I would also like to highlight what we are doing as NLR on the space domain. So I've highlighted here the specific topics within space-powered NLR, what we're dealing with. So specifically on ISR, we are looking to different data sources. So both optical SAR imagery and also hyperspectral imagery. How can we combine that with data fusion algorithms, but also by using AI to make the process more efficient and effective? And also looking towards the operational use of the data sources, where we want to see, okay, how can we more effectively task the satellites, for example? How does that work in a military context? And that is also one of the things that's then related to our multi-domain operations, where we want to simulate in a battle lab environment to see, okay, can we play out different scenarios, how they would like to acquire specific space data, where we want to bring the space domain more into these multi-domain operations for training, concept development, and also mission analysis. Then for early warning, that's where we as NLR are involved in a European project for DSII 2, where that's a European Defence Fund project, where we want to see if we can provide early triggers for ballistic missile launches, and also being able to detect and monitor and track these kind of missiles during their flight. For precision navigation and timing, there it all has to do with the robustness of the navigation signals. So this, of course, plays quite an important role in the autonomous vehicles, which rely partially also on the Galileo GPS signals. And there we want to investigate how robust are these signals? Can we provide additional authentication algorithms? And we as NLR are also involved in monitoring the availability, the robustness, and authentication of these signals. And another field of research that we're doing is if we can investigate alternative position identification and timing methods. So for example, using open source signals from satellites, if we already know their own position very accurately, if we can capture those signals, if we can then re-triangulate our own position, that's one of the research topics that we are involved in as well. Finally, for satellite communication, there we're more involved in the space avionics, so providing support on the avionics systems, doing the R&D efforts for that, but also for satellite communication, the cybersecurity is one of the important aspects. So how can we make sure that we have a secure SATCOM link, and our research is then focused on can we deploy mitigation strategies and also courses of actions for the robustness of satellite communication. So being able to process onboard data to see if our communication is still valid, or if we cannot do that on board, what type of mitigation procedures we can deploy on ground, for example. So as NLR, we are quite involved in a number of different research topics. That's also our role as research institute within the Netherlands, where we focus on the air and space domain. And there we collaborate closely with universities, with industry partners, and also our government, from concept development up until the validation and testing activities. So that's a bit of in a nutshell what we do as NLR and where we can support. Also for this challenge specifically, as Martijn already mentioned, one of the prizes, of course, are this consulting hours for the technical side. So that is where my colleagues Rick Bosma and Arnoud van Kleef will support in as mentors. And that hopefully I've given you a bit of an overview of what we are doing as NLR on R&D and space for defense. And with that being said, I would like to briefly go over these kind of use cases scenarios where I think would be interesting to look for specific topics. So within the military operations in Ukraine, for example, that is where I think Earth observation and navigation could play a role. On one hand, Earth observation, of course, to map maybe better what kind of infrastructure is still available, but also being able to provide the common operational picture and the situational awareness, where space can then provide these kind of additional information to the land, sea, and air operations. But also on the cyber domain, if there are certain disturbances, whether those can be picked up by satellites that have a electromagnetic spectrum monitoring payload, for example, if they can map that very accurately, then that can also be a warning or a trigger to know whether you will be disturbed or not. For protection of the EU northeastern borders, I think there the Earth observation capabilities are also quite interesting to look at. So specific time series analysis or pattern recognition for certain troops that will be built up there. If you can have those early warnings as well, I think most of those data can also be acquired from space. Of course, within Europe, we have the world-class technologies already on the civilian side. So with the Sentinel program, for example, I will also be interesting to see if we can leverage that kind of technology and insights also for the specific military domain and the military operations. Security in the Arctic, I think that provides something similar again for Earth observation, but also something interesting maybe for an Arctic background where you have maybe less specific features where existing algorithms are already trained on. If there are specific algorithms that need to be adapted to this to be able to extract the most out of this use case. Then the maritime security in the Mediterranean Sea and in the Red Sea. There I'm thinking more about the detection, monitoring, and tracking of dark vessels. With dark vessels, that we mean the ships that have turned off their AIS transponder, which most of the ships actually have turned on to let other ships know where they're sailing. But for these kind of ships that have these turned off, you might have an early trigger for things that might be going on, something fishy or some suspicious behavior, and then you can maybe follow up with more specific observations from space with higher resolutions to see if something else is going on, or be able to track the movements of a specific ship. Then on the topic of hybrid warfare at EUDIS, including electronic warfare, that is very closely related to the electromagnetic spectrum disturbances. So there, I think the navigation and communication solutions could be quite interesting to look at to make sure that you can still navigate through a GNSS denied environment, or if you're dealing in an area where the communications are jammed, how can you still provide a robust communication line, for example, with laser satellite communication? That could be maybe one of the options, but there, would be interesting to see how that could work out. And finally, for the missile defense, as mentioned earlier, space-based early warning. So being able to detect, for example, launches from space or movement from these missiles in flight. Always one of the most interesting ones there is to provide a sensor network or solution for the hypersonic vehicles. That is also always one of the challenges, where the hypersonic vehicles are posed as one of the threats that could fly under the radar of the existing defense mechanisms. So with that, I hope that this gives you a bit of inspiration and insight on these kind of topics. But of course, if you have other solutions or ideas on the specific use case, we will also be very interested and willing to support in that. And with that, I would like to close my short presentation. Happy also to take any questions if those arose during my presentation. Thank you.
Hey, thank you, Sonny, for these inspirational words. So I wonder now why we only have 2.5 days and not 27 or something. So because we cannot cover all the elements which you addressed. But thanks. Are there any questions from the audience?
Yes, I would like to ask about sources, more sources to research the topic of the already existing solutions you mentioned, actually. So to get more into details, could we get those as well?
Yeah, that's a good question. I think, do you mean, if I understand your question correctly, you want to have more sources on ongoing projects or initiatives?
Exactly, because like Sentinel, I can get this from Copernicus, but there are probably some topics you mentioned covered by NLR, and if I would like to go deeper and to research on that.
Yeah, so I think for the specific projects that are dealing with R&D on space, I think one of the sources that are quite useful would be on the EDF website. So there, within the European Defence Program, there's always a couple of space topics as well. We have been participants in those kind of projects. So one of the space-based early warning projects I mentioned, EUDIS 2, that is one of the initiatives that are ongoing. So I can definitely recommend to keep an eye on that, the EDF programs. It could be that it just gives a very brief overview of what the project entails, because all the technical details are mostly for the consortium members and under NDA. So it might be a bit more difficult to get a full scope of the entire project. But I think if you can, if you go through the granted EDF projects from the past few years, it could give you already an insight in the direction that they are going. But also the EDF financial framework document that should also give a direction in what kind of capabilities they're looking towards. I hope that answers your question.
Oh, yes, thank you. That's a good lead actually to follow.
Okay, then we have a question in the chat from Egor. He asked, where can I find more information about what NLR is doing in the fields you mentioned, for example, the P&T domain?
Yes, thank you, Igor, for this question. There is some more information on our work on P&T, especially more on the civil domain on our website. So I can refer to that. Specifically for defense applications on P&T, then I would also refer to our technical experts and maybe also our mentors who can provide more context on that.
Does it help you, Egor? Or do you want to specify a bit more? Yes, thank you. Okay, good. Any other questions? Then I have one. You mentioned several domains and several topics which NLR can support, play a role, and so on. Considering the strategy of the national MOD, what would you think would be nice in the context of the hackathon to further discover? Because we also have got all kinds of funds are being available, so there's a large mechanism now being developed, or it's already there, about doing business with defense. Where can young developing companies, startups focus on from the topic point of view to say, hey, this is an interesting one?
Yeah, so that's a good question. I think recently the Dutch MOD has also released their strategy policy regarding the industry partners, how they want to connect with them. And one of the topics or the domains that they mentioned was also space. So there they have defined on a longer term where they want to focus on and where they see very good collaboration also with industry partners, where they need the help from the industry partners and the research institutes. And there they've laid down a couple of topics which align with the ones from Challenge 2, so Earth observation, communication, and P&T. But it details a little bit more on how they see it and also time-wise, which kind of capabilities they want to build up. So I can also, I would say have a check on that document as well. I think it was published earlier this year, so it's quite recent as well.
Do you mean the STRIJK document?
Yes. Yeah.
Okay. Yeah. Okay. I will put it in the presentation, which we will send around. Okay. Then a question in the chat. When it comes to various topics, missiles, defense, and so on, you suggest certain solution or ongoing initiatives. Are there sources or people we can talk to in order to discover the issues related to these categories? For example, missile defense, what the current issues are, so we can see how we can improve or innovate upon. Maybe I will start answering this one, and then you take over, Sonny.
Yeah.
We have, during the hackathon, we have mentors available from not only from NLR, but also from TNO and the Ministry of Defense. So I think if you speak and meet with all these mentors, I'm quite sure you get more insight in the topics you raised. On the other hand, I also expect that it might be not too detailed enough, the answers which you hope to get, because of the confidentiality, of course, of certain of these issues. But I think the documents, I think also the STRIJK document, which I will enclose in the presentation, also specifies on certain topics, stresses the importance of it. But maybe Sonny, you can add something to this.
Yeah, no, I think I fully align with your answer as well. I think there might be some specific topics within the missile defense that are more sensitive. So I'm not sure if you get all the answers there, but I think talking to the mentors during the hackathon is very useful. Also, if you can talk to people from the MOD as end users, then yeah, I think they can give a better picture of yeah, what the most pressing issues are at the moment for missile defense.
To follow up, and I think just a bit of a side discussion. German MOD just announced a massive investment boost to space, even project willingness to develop defense capability in space. What's your take on that? What's the effect on that decision makers given the context, this overall trend? Well, it's I think it is now 1 month ago, 3 weeks ago, 5 weeks ago that a special division of the Air Force has been renamed Space. Has the name Space in it. I don't know the full name, but there's a heavy emphasis on space applications and technology. So yes, there is an increasing appetite, and also Sonny mentioned, of course, like every development from brick one on, and I'm quite sure Michiel will also address this topic about the interest of space. And from the funding side, yes, of course, there's the NATO budget increase, the 3 and 2%. There's national funding available. There are all kinds of more on the organizational side, like how to align the procurement instruments, so doing business with the industry. So yes, there is a heavy involvement and heavy growth of projects and funding availabilities, but most of these, in my opinion, most of these are quite young, especially the national instruments. But any other remark from your side, Sonny or Michiel, please do.
Yeah, I think the question also asked about offensive capabilities in space. I think that is maybe a bit more related to challenge 1. So if you're looking towards, okay, how can we protect our own space assets? We also need to have a better understanding of the current offensive capabilities in space. So I think on that side, being able to better understand the offensive capabilities, that's also necessary to be able to protect your own space assets. So that is also what I think, yeah, have been taken an interest by other institutes, partners as well, to look into, okay, what kind of offensive space capabilities are there, and then can we develop counter space capabilities for that.
I hope this answers the question a bit. All right, great. Then I know you registered here, so looking forward to discuss this with you during the hackathon. Okay, in case there's no other question, then again, Sonny, thanks a lot for your presentation and the content you shared with us. And let us then quickly go to Michiel Selier. He is the project manager of the PAMI-1 mission. And Michiel, the floor is yours. So
yeah, thank you. I'm going to try to share the slides, hopefully. Set them to presentation mode. I hope. Do you see presentation mode?
yes.
All right. Yeah, so hello everyone. My name is Michiel Selier, aerospace engineer by background from Delft University. I actually did work at NLR in the, I would say, first part of my career, now doing a bunch of other things, including now especially the PAMI program. And I really would like to thank Sonny for setting the wider scene, because this project actually ties in very nicely in to what you have sketched, and then in particular the ISR domain. So we're going to dive a bit deeper into one of the topics that you mentioned from the defense and space agenda. So Very briefly introduce to you Action Systems, because we're a relatively new company in the Netherlands ecosystem. Then I will tell you a bit more about the PAMI-1 mission and also how we are trying to build a supply chain beyond PAMI. So I would say really building wider capabilities in the Netherlands. And finally, I've done business with the Ministry of Defense more or less my entire career, on and off. So quite a lot of experience with defense and defense innovation. So I have a few, I would say, tips and tricks for maybe the people that will be in the hackathon to consider when you're actually doing your work there and coming up with clever solutions. So I hope that helps. All right, first Action Systems BV. So we are a relatively new company. We are based in Delft in the Netherlands. We are a subsidiary of Astrion, which is a US-based company. We were founded in 2024, and we are definitely currently growing our team in the Netherlands I would say, especially for the space domain, but there's a few other things that we do as well. What does Action Systems do? So we are a system integrator. So it is not our role in the ecosystem to develop hardware products as such, but more combining innovation and products from other companies into a defense mission capability. And you very often see that a mission capability is not relying on single technology. You bring a few Lego bricks together, so to speak. And our expertise especially is making sure that those Lego bricks fit together very well, but also that they match very well the use cases and the demand of defense operations. So we can play sort of an intermediate role between translating defense requirements into, I would say, satellite or mission requirements. Active in 3 areas. So in space missions, that is one, and in particular in the small sets, which I will also explain on a slide later, that is quite some bigger than the CubeSats that the Dutch MOD currently has flying in space. We're also focusing on critical asset security. For example, if you have a Danish airport and you want to protect yourself against drones, there is a whole number of technologies that you could use, like radar systems, but also maybe systems to disable any drones, etc. And typically, Action takes the role to tie all these systems together into an operational capability where you can detect and assess the threats and take the threat out if needed. Also, we have a branch on modeling, simulation, and AI, and currently also for the Ministry of Defense, we're doing a project, a sort of pioneer project also on AI synthetic image generation. But let's focus on the space missions for now. So go to the PAMI project. I'll explain what PAMI stands for in the next slide. But what we are trying to achieve is actually twofold. So first, we are trying to provide to the Netherlands MOD a sovereign space ISR capability, which allows the MOD to have its own sovereign tasking and get the information as quick as possible to the end user that needs it. Currently, especially for these larger platforms, the Netherlands needs to rely on other countries with such assets. And of course, you can ask those other countries, I have an area of interest, please provide me some space data. But they also have their own areas of interest. So you also, you always need to see whether or not you get the information in the first place and how long it takes to actually get that information. So that sovereign capability with sovereign tasking, being able to control very quickly what you want to see from space, that is, I would say, the defense capability that we're after. But in parallel, we are also strengthening the Netherlands ecosystem, and in particular, I would say for the small satellite manufacturing capabilities and also subsystems. So far we have CubeSats. Also, so far the Dutch ecosystem has been, I would say, quite a lot civil oriented in the past, and now it's also in being able to provide sovereign capabilities. We want to be able to manufacture satellites in the Netherlands, and therefore you need an ecosystem that is actually capable to do that production and sourcing. So So what is PAMI about? The 4 letters for PAMI stand for the P for payload. So it's developing, I would say, very capable payloads, ISR payloads that allow you to get good imagery from space. The A stands for assembly, which is very much tied to the production capability. So the satellite bus that we have is actually an existing satellite bus from Blue Canyon Technologies from the US, but we will build up a manufacturing capability at VDL in the Netherlands. So making sure that we in the Netherlands also have these manufacturing capabilities. Then mission integration, that's the M. That's the role of us as Action Systems to bring all the building blocks together and turn it into a capable operational satellite. And then the I stands for inter-satellite link, where we are going to fly 2, I would say, proto-flight models, the Resolite 50 and Resolite 80 from laser satellite communications. And those are demonstrators, but yeah, those are specifically meant ultimately to also allow maybe in a constellation, for example, to have inter-satellite links so that you can get data as fast as you can to the end user. So yeah, mission integration in the center, we're bringing it all together, and we need to tie it to the MOD operations in the Defense Space and Security Center in Breda, who are on their turn tasked by maybe Army, maybe Navy, maybe another entity in the MOD for a certain, I would say, information request. And the whole idea is to get that data that they want as fast as possible to the users that need it. Some statistics, I would say, on the mission. So we'll fly low Earth Sun synchronous orbit, around 550 kilometers. We are basing the bus on a commercially available small set where we integrate the payloads upon, and in total, we're getting a platform that has 450 kilograms of total mass. And as mentioned, Blue Canyon Technologies is having this manufactured, the bus manufactured at VDL ETG, and also Axient will have the satellite integration. So adding all the payloads to the satellite bus, that will also happen at VDL in Almelo. We are planning to launch this satellite in 2028 and have a mission lifetime of 5 years. I think I already more or less addressed the payloads. So we have an electro-optical imager, multispectral imager, and the 2 laser SATCOM terminals that are used for mission downlink. But in addition, we also have normal radio frequency downlink as well. I'm not quite sure with the audience beforehand how familiar everybody was with I would say the size of these vehicles. So, for example, the brick that was also mentioned by Sonny, thank you for that. That's a CubeSat that has, yeah, I would say the milk size, milk package size, yeah, size. And the PAMI is actually more, I would say, small refrigerator size, so to speak. So it is really a bigger platform that needs higher reliability, longer life, and the idea is also to get some high quality precision images, and that poses, I would say, on the integration side, some interesting challenges for us on the maneuverability and the stability of the platform in order to get good quality images down. So that is, I think, what I would like to say here. Then who are the team that we are, I would say, bringing together? So I would say this is a very good example of the triple helix cooperation, as we call it in the Netherlands. So we have representatives from the government, Ministry of Economic Affairs, and the Ministry of Defense Space and Security Center. We have an industry consortium where you see, let's say, the key partners on the top line. So Cosine for the payload, Blue Canyon and VDL for manufacturing, Axient for the mission integration, and FSO for the laser SATCOM. But we also are including some other technologies from the Dutch ecosystem on software, on solar panels, on propulsion, and very much supported also by the knowledge institutes in the Netherlands. So Also NLR and TNO and TU Delft we're keeping close ties to them in the project as well. Another reference document that you might want to look at if you want to know a little bit about what Ministry of Defense wants for capabilities is the DSII, so the Defense Strategy for Industry and Innovation. I think it's publicly available, that document. You can just Google it. And the motto there is sterk, slim en samen in Dutch, which basically means strong, smart, and together. And I think that very much also describes the good cooperation that we have in the PAMI project. What is good to tell also is that we are bringing these capabilities together now for the Ministry of Defense. However, we also have a clear desire to go beyond the PAMI domain and also beyond the defense domain get also mission as a service type of capability for potentially also for civil domain in there. And the key reason for that, and that's also one of the tips I have on the next slide, is that you need to make sure that whatever it is that you come up with as an idea or a solution, that there is a good business case for it. And a good business case usually requires a volume and a steady flow. You can sometimes develop something that can survive only with a defense, I would say, demand. Sometimes because of the nature of what you're providing, it can only be defense. But for some other capabilities, especially if you need to invest in your ecosystem and in test facilities, etc., then it's always very good if there is a wider demand. So we are definitely also looking beyond PAMI to bring all these parties together to work on the small SAT section. Make sure that I would say everybody in the Dutch ecosystem can step up, which is one step on the ladder for the supply chain. That's the ambition that we have. That said, my final slides. I would say some more personal recommendations or tips for hackathon challenge for the MOD is that for defense, in the end, operational impact is what counts. Technology is very cool. I'm an engineer myself, so we really like technology. But especially when you start talking to MOD, and I'm really happy to hear they will be present at the hackathon. So I really also encourage you to talk to these people. Because in the end, they are not looking at, okay, you have beautiful technology, but how does this matter for me in my daily operational reality? Also, depending a little bit on the idea that you have, it is also worthwhile to consider if you have a certain dependency on a certain infrastructure, which may or may not be present already. A good example of that I frequently use is the toilet. So the first toilet that can flush is somewhere from the 1500s, but it took about 300 years before it was widely spread, because if you don't have the infrastructure to actually get rid of what it is that you're flushing, you don't want to have a toilet in your house. So, and there, of course, are other trains are a very bad invention if you don't have train tracks, etc. So it's always good to think, okay, how does my idea fit into the operational infrastructure? Another thing to consider is your idea robust in a wartime scenario? And we've already mentioned the threats that are also very real for space assets. You, especially if you really get into a conflict scenario, you must also consider the fact that some of your space assets will be destroyed or tampered with or something. So you need to find a solution that makes them more robust, or you need to be able to, let's say, replace them very quickly in order to keep your capability up. Then already mentioned the business case and the use case and the business model. What are you basing it on? Is it only defense? Is there dual use application? That also really helps to turn an idea into maturity. I would say if you know more or less which market you can serve with it. And another thing that is definitely important for the EU is strategic autonomy. So if your idea is reducing dependencies on technologies from outside of the EU, that is usually a very good thing. That said, my last slide, so open for any questions.
Thank you, Michiel. Who there first?
I would have a question, actually. Maybe that's something for later, but I'm just curious. Do you or how do you handle anomaly detection in data quality? Because if you're gonna send a lot of data, there can be like some problems with it. And do you handle it like after the reception of the data, or after the like first analysis of the data, or are you still working on this?
Yeah, excellent question. Thank you. So in PAMI 1, we are not looking at the moment at elaborate onboard data processing, but that is definitely an area that I think is of interest in general for ISR capabilities. Specifically, if you have, I would say, optical payloads, and I mean, if you have pictures of clouds, for example, you may not want to send them downward in the first place because you won't really see anything of interest. So there's definitely, and I think that is an ongoing trend also in space, is to look at, okay, can you already do some smart processing on board? So that the data that you send is the most relevant. But that said, I think most of the actual combination of data tends to happen on the ground, because you may also want to tie it together with other assets. So there could be other airborne assets like drones, other land-based assets that also collect ISR. So it really depends on the use case, I would say, whether it makes sense to have these type of capabilities on board, so to speak, or whether you want to do that in a joint operational picture type of fashion.
Okay, thanks.
Maybe any insight, Michiel, in the multimodality aspect of combining sources?
Yeah, so that's not really what we do in PAMI, as mentioned. It's just taking good imagery and sending it down. That is, I would say, the core of what we're initially doing. But definitely for the defense, like I said, it is always of interest to combine various information sources, and that is something that we as Axient are also doing. For example, the example that we heard recently on ships that are not broadcasting their AIS, for example. We have already done some demos also actually for the Netherlands government for scanning the North Sea. Where you could integrate data from space or data from aviation-based platforms together with AIS data, ADS-B data, and various data sources. Maybe some radar elements stuck on wind farms or whatever. So you could have a multitude of sensors. And this is typically something that Axient System does, is, okay, so how can you bring all this data together, and how can you do smart detection of, I would say, areas of interest, objects of interest, these type of things. So it is definitely a research area. And now with the advent of AI, I would say accelerating, where the key challenge for AI is actually to make sure that the AI is not hallucinating and coming up with basically distracting you on something that the AI thinks is interesting, but actually is flawed. So trustworthiness of AI is also something that is, I would say, you see that also in European research that Sonny also mentioned, is trustworthy, explainable AI is also something that is very much researched in Europe in general, but definitely also in the defense domain.
Mm-hmm. Yeah. Okay. Any questions from the audience? If not, then I would like to ask one thing more, if that's okay.
Sure.
You mentioned very shortly the element of synthetic data. Where do you think the value or the value of synthetic data is for defense?
A good question. So we are currently doing a project on synthetic data for the Ministry of Defense also, and the use case that we are looking at there is, if you look at how war fighting has changed in the Ukraine, you see that there are innovations are very fast on the battlefield at the moment, especially drone-based things. So there's drone-based detection, where you can maybe detect a tank, and then the adversary starts to notice that your drones are getting very good at detecting their tanks. So what they do is they will try to mask their tanks. You have the turtle tank now, for example, which is basically a shed with a barrel. They just build sort of a shed around it in order to avoid that automatic detection models are picking up on that. And the whole thing with synthetic data is that if you have a limited amount of real data sets that you want to train an AI on, then you need more data in order to train the AI detection very good. You need synthetic data. So the idea is with synthetic data very often, and that this is one use case, but there are plenty of other use cases, is especially for generating training data for other AI, so to speak. That is something that we are working on.
All right. Thank you very